made it possible, and especially in Austria, I've learned a very recent development. I give the title of the talk, which actually explains it: Science that makes an impact. How artificial intelligence is redefining progress.
So, hello and good afternoon, everyone. As I said, I am probably the farthest away from a scientist of all in these rooms, as I've been out of science for the last 10 years. But what I'm trying to talk today about, and I think that's in the spirit of this whole lecture and Wilhelm Exner and the whole building we're in, is how to be both in science and industry and how this can be bridged. And I think the talk that we heard by Professor Hochreiter is exactly illustrating how we can bridge these two worlds and how we can proceed on that. So we proceed without slides, which is not a big problem. You just have to listen more carefully until the slides start running. So let me briefly introduce myself. I did a PhD in bioinformatics quite some time ago, and what I was working on was trying to use machine learning in order to analyze biomedical systems, to understand their dynamics. And one of the fields I was working on was plant genomics, which is again a nice link to what you just showed before, because we used machine learning and compute, which doesn't work at the moment, machine learning and compute in order to understand how plant genomes work. We were the first to decipher the wheat genome, which then would lead to the next revolution in plant science and agriculture. As we have seen how a wash is the industrialization of nitrogen, then the green revolution in the 60s, and now precision breeding and the application of, yeah, I can get this somehow, and the application of the application of precision breeding, genomics, and targeted genetics in order to improve plant growth outcomes. After that, I joined the dark side, if you will. I joined consulting for the last 10 years. I was working with companies, industries, helping them on their digital transformation, helping them to do their data and BI strategies in order to reap the benefits of research like we've seen by Professor Hochreiter or the other speakers. Just recently, I have joined BFRD Austria, which I will talk a bit about during the next 15 minutes, as a co-lead, where we are working on exactly this, bridging the excellent research we have in Austria with applications in industry, with applications in public administration, in order to improve basically what we all are striving for: more money for fun stuff, less taxes in the end, and more benefit for the society. What I've learned when I joined consulting after spending several years in science was that there are several things that can be transferred. It's the methodical approach to problems. It's the curiosity, the drive to learn new things very quickly, to adjust to uncertainty, and to work with new people and to work in collaboration, to work interdisciplinary. What I also learned, there are certain things which can be transferred that easily. For example, when we are good enough, and a nice example of that, sometimes you don't need the perfect solution. Sometimes a good enough solution is enough to solve your problem, especially in industry. I always say industry, in most cases, don't care about the expensive point. They just want to get more buck for their money. And that's exactly what we have seen before. If a small language model solves your problem in an adequate way, it helps you improve the production, it helps you to reduce costs, it helps you to be more efficient in your production. And it's good enough.
We cannot produce it from here. There's two possibilities. You go on without the slides, or we transfer it and make a short break.
I can.
It's your decide.
If you don't mind, I can describe what's been on the slides.
No.
But I will just keep on talking. You have to listen to my voice. I'm going to try to be more emphatic, more dramatic in my gestures in order to keep you entertained. But the slides are anyways just the by-work, the visuals for what I'm doing on my audio, so to say. And I think what's quite important today is, as we are in this building here, what we've heard about Wilhelm Exner, what we heard about Professor Hochreiter's work, I think two things we have in common if we come in this building. One is that we believe in the scientific method, that we all have a certain curiosity, that we all want to bring certain advantages, that we want to bring new things to the table, that we want to improve what we know, and we want to improve what can be known. But secondly, and I think that's the big point about Wilhelm Exner, about the work that we have seen before, it's not enough just to know these things, we need to bring these things into practice. We need to think about how can this be employed, how can this help the society, how can it help each and every one of us, how can it help companies in the end, because everything we do is funded by some money, and in order to get this money we can either rely on US and Chinese sources to get us this money, or if we try to produce this money on our own, which is the way I would prefer. When preparing for today's talk, I was talking to my 15-year-old son, and I don't know if you have teenagers at home, but I can tell you they're very seldomly, very rarely impressed by your work. They find it totally uncool if they even talk to you. But when I told him about my new job working on AI, what we do at the AI factory, he actually looked at me for the first time in quite a while and was like, "Hey Dad, that's actually pretty cool." Which I was like, wow, I haven't heard that in quite a while from my son. And if you have teenagers at home, this is really something to be proud of, firstly. And secondly, to me, it also showed how much we have come, how far we have come from 1956, where we had the first papers talking about if there could be something like an artificial intelligence, to a thing that's being discussed in classrooms, on TikTok, and even on kitchen tables between families. So this is really, really, really a huge, impressive journey if we look at it. It's only 17 years that we look at, and everybody's talking about it now. What I want to talk about today, without slides obviously, is how we could manage this journey from science into practice, into application. And I really like what you were talking about before, Professor Hochreiter, this idea of basic work, industrialization and scaling of these ideas. And already in 2018 there was a book, AI Superpowers, by Kai-Fu Lee, former executive of Google and Microsoft. And he wrote back then that we are entering the age of AI implementation, where AI makes the leap from pure academic research, or mainly academic research, into application, into real-world software, into everybody will feel the effects of AI. And 2022, we were at the edge of Corona, I would say. We all remember the early demos of ChatGPT that changed our perception of AI forever. Now, everybody can use it by the tips of their fingers. And for me, this transformation is best exemplified of how we listen to music. If I remember back then when I was a kid, I was around 6 years old, I had to know my vinyl player, my cassette tapes. For those of you who are really, really young, vinyl tapes are these round things that look like a tire. Yeah, I remember. And what we had to know, we had to have certain technical skills. We had to know how to place the needle just right on the vinyl to play the right parts of what you want to hear. You had to select the right speed, and then you could hear Vicky and die starken Männer, Biene Meier, whatever there was out there. If I compare it with what my 4-year-old daughter hears today, she just tells our AI assistant what she wants to hear, and within seconds, from an endless library of selection, the AI agent selects something she wants to hear, and let me assure you, if it's not what she wanted to hear, there's going to be very direct and valuable feedback to the AI. But if you look at this leap into implementation, we see a much broader shift, and similar to what you have said, Professor Hochreiter, Kai-Fu Lee argues that there are 3 necessary pillars for this transformation. One is data, we heard about that. One is compute power, and the third one, he argues, is strong AI engineers and talent, people that can do that. Let's have a look at data quite quick. So in the early 2000s, when I started with my studies on machine learning, the field of human genomics was at the very beginning, so it was 2003, 2004. We had the first draft of the Human Genome Project. It was about 90% complete, which was impressive back then. It was really the best you could do with the technology available at that point in time. And then it took till 2022 till we got a fully sequenced human genome by the telomere to telomere consortium. And this was for the first time that we really got a truly completed human genome. But what's even more impressive, if you look at the numbers, if you look at what's the outcome, that the price of the genomes has dropped from 10 millions per genome in the early 2000s to a couple of $100. And this underlines also here exactly what Professor Hochreiter was about. We started with basic research, we did industrialization, we developed the machines to do sequencing, and then we could scale up. And the second thing, which is also quite nicely fitting to the AI model, we started with a genome that was a pool of all different types of genes. It was 10 people, I think, was the first genome. Then we had a breakthrough that we could sequence single people. And for a couple of years now, we can look at single cells and sequence single cells and really predict, analyze, and diagnose single cells. So we have exactly what you said. We scaled up, and now we're scaling down again to really get this precise information. And this is not only true for life science. If you look at IoT, if you look at satellites, if you look at all different domains, we see this explosion of data generation, which is kind of interesting because it leads to a dichotomy of things. On the one hand, if you talk to people, they are all asking, how do we handle this plethora of data? How do we deal with the IT department being overloaded by this data because it's just too much? How do we ensure trust in this data? How do we manage this data? Who is the owner of this data? This is the one hand of the problem. And the other hand is, it's still not enough data for certain models, so you really have a quite interesting situation. Huge IT costs for data, on the other side, the data is not enough. And how can we solve this problem? And the answer to me is, there's an old principle in machine learning and data science that has been true for the last 70 years and longer. A good data foundation is king for everything. If the data is not good enough, you don't know your data, then you must not even start with the journey. The second thing he mentioned was compute power. So when I started machine learning, data science, whatever you want to call it, the first thing I learned is there's never enough compute. So whatever you do, you're always going to run into a memory leak, you always run into some problems with your memory. And I remember quite fondly back then in the early 2000s when we coupled to PlayStation 3, because back then the cell processors of these things was for numerical operations the best that was out there for a cheap buck. And we thought if the Navy can do it for like 1,000 PlayStations, we can do it for 2 and give it a try. The overhead of communication ate up all the benefits of supercomputing, but at least we tried and it was quite a fun time. Today, computing is 100 to 300 times cheaper than it was back then. It's a good thing. On the other hand, the demand has by far outpaced the availability and the cheapness of compute. If you look at what's being built today and what's invested today, it's supercomputing. And I'm on your side. I'm not sure if more and more supercomputing is the solution to everything, but it's more supercomputing in elasticity for smaller products and the smaller models in the end. But if you look at the available things and what's being built, modern AI is really eating up all supercomputer we can get. And what's quite interesting, we run into quite some troubles, because if you look at the manufacturers of these things, they are quite monopolistic, oligarchic organized. So any surge in demand, any huge data center, compute center being built, or any geopolitical hiccup, if you look at the Netherlands, can lead to huge problems in your AI pipeline. The other topic that everybody's talking about, power consumption and cooling, and we heard there's going to be less energy used for single models, but if you have lots of small models on the other hand, consumption goes up again, so this is going to be balancing itself out. So it means we have to think about how this can be addressed. Today, estimates are given that we have 1.5% of the power being consumed by data centers, 3% by 2030, so we have to address this. And the third thing here is that we see a global arms race. This is also something that you mentioned. The US and China are heavily investing into data centers. They're building it as if there's no tomorrow. They have nuclear plants being built, they have small nuclear plants being built and tested. Europe is trying to catch up. There are certain initiatives in Europe to try to work to that, like Oro HPC, gigafactories, and so on. And we're trying to invest into chip making and supercomputers, because I don't believe that the demand is going to slow down. It's going to be different, but supercomputing is going to be a topic forever, as you said. So what about the third ingredient, talent? I was quite happy to see the title AI engineer on the LinkedIn post that you shared, because back then when I started, AI engineer was quite a rare title, so nobody called himself data engineer. There were software engineers doing AI, or there were software engineers for machine learning. Now we see a huge demand for people who can really be AI engineers, people that can build a system, that understand these systems, and that can basically put these pieces together that you have shown in order to make it work. Like the question before, how do you make it work? Get a bunch of really good AI engineers that understand their business, get their hands dirty and start working. So what do we need in order to build this? What do we need in order to have a system that a 4-year-old can command, or a system that can diagnose cancer? You need to have a robust supply of AI talent and engineers. So if I look in this round, probably the majority of you working with AI, so I'm quite confident that we will be working on that. On the other hand, it's not going to be enough. We're going to need more people. We need people that understand this, and that's why I'm with you, Professor Hochreiter. There's going to be certain jobs lost. This has to be stated as it is. But on the other hand, there's going to be new jobs gained. There's going to be new job profiles. And if I think about my juniors, I do not dare to give them job advice now, because I don't know what in the next 5 years the job's going to look like. So prompt engineers, I don't think the prompt engineers are going to be needed. There's going to be different job profiles that we maybe I cannot even dream about. So this is really something where we have to invest in. If I look at this round, I'm quite confident that Austria and Europe has the right pipeline for that. So closing out, this brings me to the question, what do we need to get from this curiosity to competitiveness? For me, one of the first pillars for this is culture. I just recently spoke to a startup founder who moved from the US to Europe, and to me he explained the biggest difference between US and Europe is, if you're in the US at the university and you have a bright idea, have a great idea, you first thought is, cool, I'm going to build an enterprise, I'm going to be a founder. If you do it in Europe, you might think, okay, I have a tenure secure and a secure career for the rest of my life. And to me, it's not an either or. I think the strengths that we should build on is to really have not contrasting academia and enterprises, but we should see them as complementary and permeable. A vibrant ecosystem which we are building and which we urgently need in Europe allows people to move, as you have shown, that where you have an idea, where you do the academic research, where you write the papers, but you do not stop there because you say, okay, I have to see it in action, I have to see if it's real, I have to see if it works, and really take this idea, put it into action, give it a try, do a waterproofing, see if it holds, if it floats, if it sinks. And this also means that we have a culture that needs to allow failures, because if we only measure people by success, nobody will be successful. So we have to have a culture that allows us to try things out, that allows us to fail, that allows us to be bold, and also fall on the ground, but again, help you to be lifted up again. And we also need a culture of collaboration, which I think is great exemplified by bilateral AI, by the AI Factory, and by all other projects where we really learn it's not enough to be just a good computer scientist, it's not enough to be a good AI engineer. The collaboration with the domains, the collaboration between scientific, industry, applied research is this where we have the strengths where we can really excel in the end. The second pillar is confidence. So if I look at Trustworthy, we had seen it before. If I look at the numbers of trust in AI, in Europe and US, it's around 30-35% of people who trust AI, who have a positive attitude against AI. If I look to China or India, it's 70%, a bit more even. So what does it tell us? It tells us we do great research. And we have seen we are leading the leaderboards for certain models, but we still fail to translate this leadership into trust in the broader audience, in the industries, in the citizenship. People in Europe and the US are still, why do I need this thing? They always have worked without that. So we really need to be bolder in that. And one number I liked, and it's quite nice that you have shown this as well, there are studies out there that show if you only use the available AI measures, the available AI tools that we have already now, in Austria it could increase our productivity by 18% in the next decade. And given the budget constraints that each of us is facing, given the social constraint that everybody's seeing and facing because of the budget cuts, if you had 18% more productivity just by using what's already out there, imagine what could be done if we use what's going to be developed in the next years. And also, leading to that is, we should stop asking, can we trust AI? We should ask, how can we build the AI that can be trusted? And I like the talk by Laura Kovacs before, how can we build systems where we can trust, maybe not blindly, but at least confidently that the output is trustworthy, applicable and automatable. The third pillar I was talking about is commercialization. We are great at producing talent. If I look in this round, we're very, very excellent at producing talent. We are good at producing IP. And then, as some expert told us, US companies are coming to Europe to shop. So they're buying our IPs, they're buying our talent, build up their services and sell it back to us as premium services and different cloud providers and software packages. So we have to think about how can we commercialize, how can we become more attractive, not on the innovation, but on the commercialization, on the implementation, on the industrialization in the end. The good thing is Europe is doing something about it. So there is, like yesterday was a conference where Europe started to invest, where Europe started to talk about how do we get to a point where we can catch up the lagging behind to US and China. What we need to do is we need to close this gap between innovation and implementation and grow our own AI champions, and maybe NXAI is going to be the next AI champion that we see on the global scale. The last pillar we need to talk about is commitment. Not just excitement about, cool, I did a prototyp. Not just pilots that everybody's happy about, but we need deep, sustained commitment from all that are involved. From policymakers, that we reduce bureaucracy and fund impact and outcomes. From industry, that we really reimagine value chains, like you said, and not just automate the old ones and get a small increase versus getting a big reinvention increase and big production gains. And from science. Science needs to continue to advance knowledge while at the same time engaging with the outside, with engaging with businesses, with the with the public administration. How many times do you hear from scientific partners, if you do not understand it, you're not worthy of using it. This is really helpful if you're talking to industry because they don't have the time, they don't have the skills, they don't have the resources to deeply understand each and every bit. They just want to get the problem solved with the level of understanding that you said good is good enough sometimes. And we need therefore science that is transparent, teachable, and translatable, so that we have businesses, governments, and citizens that can really benefit from what is being built in our academia. Closing out, looking at this, pausing here and looking at you, Professor Hochreiter, I strongly believe that Wilhelm Exner, if he was alive today, would not ask, what is AI? I believe he would ask, what can we do with it? What can we produce? What can we do that has not been done before? And therefore I do think that curiosity alone is not enough. Knowledge alone is not enough, and impact only arises if you have excellence, means, and collaboration together. And I strongly believe that Europe has, in this age of implementation, everything that we need. We have brilliant minds looking in this group again, looking at you especially today. We have brilliant minds. We have strong values, and we have a growing sense of urgency. Like I said, if your deadline is coming nearer, you automatically increase your productivity usually. So we have to act now. So we really have to be courageous to build something. We have to be clear on what we build and why we build it. And we must build these bridges between science and business, between research and application, between what we can imagine and what we can really implement. And therefore, I would call to action by saying, let us not be the generation that just witnessed the AI revolution, and you are a perfect example for that, but really let us be the generation that shaped the AI revolution and made something out of it. So thank you and congratulations for your trial.